everyone. Hopefully this is live now. Sorry, I'm having a little confusion about if it's live or not. So say hello if you can hear me. Okay, looks like it's going. There's a delay of like 20 seconds from when I say something to when it shows up here. So looks like we are up and running today. I am not Tim Van Million. I am Michelle. I'm the office manager here at Apogee Components, and Tim is out of town, so I am filling in for him today. And I have a couple of questions prepared that were emailed in today, and I can also take your questions in the chat. I can see the chat here. Yay! If I'm too loud, let me know. The microphone is like wee every time I talk, so there is an echo. Let me try turning it down a little bit. Does that sound better? Hopefully that's better for that. So, just looking at everybody checking in. We've got Nikolai from Poland, Carlos from Marietta, Georgia. Hello, Rosa from Ottawa. And Gerald's here, and Mark Sells from Parker. Hey Mark, I got your question. It's one of the ones on the list. And Jerry, if that's you, you said you weren't going to be live, but it looks like you are. That's very cool. So, to get started, let's see, Carlos has a question in the chat. Many RKT files are on the web, some aren't bad, some are awful. Please show the top few old RockSim issues and how to fix them, or maybe when to give up. I'm not sure what you mean by old RockSim issues, Carlos, so you might need to be more specific. RKT files, the RockSim files, the ones on our website, we do, and they should be pretty good most of the time. We try to make them pretty detailed and correct. Every once in a while we'll do like a quick and dirty mass override type thing for them, but they should be pretty accurate. The ones on the internet could be made by anybody. Could be made by an expert, could be made by somebody who has no idea what they're doing. It could be a file that they don't care about the simulation part. They just wanted a picture of the rocket to make it look pretty, or something like that. Maybe they don't care about it looking pretty, and they just want the simulation parts. So the ones on the internet, it's hard to know what's wrong with them. Yeah, Jerry, I see your note about adding the nose cones to the tube fins. I have that one. You are number 1 on the list. Today I've got my notes here for things to talk about. So Carlos says common mistakes that we make. That's still kind of broad. So I'll answer these questions I have here, Carlos, and that might cover some of these things. And then maybe if we don't have any more questions towards the end, I can go through some files and some things to check that might cover what you need. There's some things that people miss a lot. Usually when I'm doing tech support for RockSim stuff, it's usually one of a couple things, so we can go over those things in a little bit, and that way things to look for if you download a file from somewhere random. So to start, I'm going to share my screen. Okay, and you can still hear me, hopefully, with this. Looks like the sound's still good, so let me know if that changes. So first thing I'm going to show you is on the website how to get to these live videos later on. So just so if somebody's viewing this, later on. You can go to How To and Guides, Software, and RockSim Live Training. That's where these are stored. So you can always come back here later. Carlos, a lot of your questions are probably already answered in the previous 50 episodes, so you might just take a glance through there if I don't cover anything. But common things are often covered here. So this is how you get to those. Also, talking about Rocket files and downloading them, we have on our website, if you go to How To and Guides, oh dear. I don't remember. We just rediscovered this the other day. We'll try just typing in free plans. We have a page with all of our RockSim files on it. No, it's not that one. I'll have to find it and come back to it, because we were looking for it the other day, and we kind of re-stumbled across it. There's so many pages on our website. I know you guys get overwhelmed by that. We get overwhelmed by that too. There's so much information that we have pages with old links on them that we want to update, but we just don't have the manpower to do it right now. So if you ever come across a broken link or a link that goes somewhere you think it shouldn't, I had one of those this week that I had to fix. Feel free to send it in, because you guys use the website and you're on it, and I don't have the time to go through every page of the website every couple of years to make sure everything's still accurate. So I will find that link here a bit later. So to start, I'll pull up RockSim. And so Jerry's question was asking about how to put nose cones on tube fins in a rocket. And one of the things that's, I'm sure every hobby is like this to some extent, but with rocketry that's kind of funny is that you can have the same part and it can be called different things. So you have a ring that can function as a centering ring, and it goes from your motor mount tube to your body tube. Or that same ring can be called an engine block if it goes inside the motor mount tube and stops your engine from going forward. And so with Jerry's question, he's asking about how do I put nose cones on tube fins? Well, by definition, a tube fin, the air, you've got a round tube. I meant to grab a rocket, I forgot. You have a round tube fin, and then the air goes through it. So if we put a nose cone on it, it's no longer a tube fin. So that's where, instead, even though it might be the exact same part, it now functions as a pod. So strap-on booster pods are real popular right now with rockets. Let me show you a kit that has them in it. And I'm going to show you how to do all this, but I wanted to give you a little trick. If you are coming back later to do a rocket, or you want to do something with a feature that's weird, like a strap-on booster, the easiest thing to do if you don't remember how to do this and you don't have this tutorial in front of you is find a kit that has that feature and download the RockSim file, and then you can cheat and just look at how it's put together. So the flying machine rocket from Apogee, my chat's going off. The flying machine from Apogee has strap-on boosters. So if you look at the kit, let me pull it up here. This kit has, like Jerry asked, it's got tube fins with nose cones on them. And so it's got these strap-on booster pods. So you could go, and if you don't have it already, you can go on the page, you can click on this RockSim file shortcut, or just scroll down on the page, and it'll take you to the RockSim file, and you can download it. The flying machine should come with RockSim 10, especially 10.3 or later. We updated all the files. So you can go into your RockSim and let's see, and all the existing files, assuming you didn't modify them, are in your RockSim, in your applications or programs folder, and then RockSim 10 and designs, and then they're grouped by manufacturer, and then flying machine. So I pulled up this rocket and you can see it's got the tubes here with the nose cones on it. So you can go to the design components and look at how this is put together. So in the future, don't necessarily need to reinvent the wheel. You can find something. I do this a lot with things that I don't use very often. Like I don't do pods very often. So I went and watched the video tutorial on how to do that. Or I would pull up a rocket like this and go, how do we do this again? How do I do dual deployment in a rocket again in RockSim? Because I don't always do those things as often. And even though I know how to do it, sometimes you forget, one key little step. So that's the trick with one trick there. The other thing I will show you real quick is we actually have a video tutorial on how to do this. So that's under How To and Guides, software, and then the RockSim video tutorials here. These are pre-recorded. They're from, my trusty assistant is bringing me a rocket. This is the airmail. This is the last kit that Apogee has released. Put that in front of my beverage. So we have our RockSim video tutorials here, sorry, I lost my train of thought there for a second. These are all pre-recorded tutorials on how to use RockSim. The first ones are re-recorded for version 10. Tim is slowly making his way through these to re-record them, but the content is the same for 9 and 10, so if it references version 9, it's fine, works for version 10 too. So quick video tutorial number 15, make strap-on booster pods. We'll show you exactly what I'm going to show you today. I actually watched this earlier just to refresh my brain in case I forgot anything there. So, and these are all on YouTube, so you can pull them up there or here. There's also attaching fins on fins. So if you want to do a T-fin, that would be, you use the pods feature for that too. And then if you want to do advanced pod design, which in that video is putting a pod, like a strap-on booster pod, on a T-fin, getting super crazy. And the simulated jet engines, kind of the same idea for that. So these are also just about these topics, so you can come here and watch those. Okay, so now we can actually get to this. So we're going to start, what I'm going to do is I'm going to open up a different rocket, just a basic. We'll use the Avion because it's just a 3 fins and a nose cone guy here. So, and what I just did was I changed the view. Sorry, I haven't done these video RockSim Live in a while, and I forget to talk through what I'm doing. I just whip through. So here you can see the different views. So that was the 3D view, and then I just sorry, went to a side view. These two are both side views. They're just rotating the rocket, so you can see how the fins rotated there. Okay, so the first thing we got to do is add the pods. So if you're using tube fins, you actually can't use tube fins for pods because the way RockSim handles fins is very specific. So a tube fin has different physics than a strap-on booster pod, at least the way RockSim, I'm sure in real life too, but the way RockSim handles it. So you can't take a design that you already had a tube fin in and just put a nose cone on the tube fin. It doesn't work that way. So the first thing we're going to do is we're going to add a pod. So you'll click on wherever the part you want to add the tube fin, the tubes onto, which is probably your body tube. And you'll come over to the right hand side and you'll click pod. So a pod in this case is an invisible glue, I would call it. It's an invisible piece that basically tells RockSim that I'm going to be attaching a part to a part. So if you kind of think of it as like the glue to kind of stick the two together. So this is just sort of announcing that. So we're going to call this pod 1 because we'll probably have 2, or you can even have 3 there. And then with pods, pods can be ejected during the simulation. So like strap-on booster pods a lot of times are popped off. The flying machine ones pop off in real life. when the motor ejection charge goes off, it pops the nose cone and detaches them. So if you want your pods to fall off, you can check this box. If you're functioning them as a tube fin type thing, they probably aren't falling off because they're glued on the rocket. So we're going to turn that off right now. You can also mark it as already ejected. I'm not sure when you'd actually use that, because most of the time, why is it there if you're already ejecting it? The location for right now, just leave it. It's hard to mess with the location if you haven't attached anything to it yet. So we're just going to add the pod, and same thing with radial position. That's the position around the rocket. For right now, we'll just leave it. So we've made our invisible pod here. So now we actually have to put the parts that we're going to make the pod for. So in this case, the tube. So we're going to add a body tube. So again, we're not using the tube fins. And oh no, my database is missing. Why is my database missing? I was playing with this because we were doing some tech support for it. So so we're going to do this the old-fashioned way. And sorry, I've got a tickle in my throat. You can choose from the database. I'm pretty sure I deleted mine out to test, and that's why they're missing. So you'll set the outer diameter of the tube. So this is a 24 millimeter mount, so I wouldn't want these to be too big. So we'll just say that, and then set that, and the length, that's probably a little short. So you can see kind of down here, it's a little small, but I have my little baby tube fin looking piece, and it is green there. So let's make this a little longer. It's a little short. There, that looks better. Okay. So we added the body tube there. And now we can go back to the pod and that location. Let's do this way. It's kind of hard to see this way. So the location, we're going to move it back because we want it to be in the back there. So we just moved it back further. And then for the radial position, I'm going to change this to a base view. So right now the tube and the fin are in the exact same spot, which doesn't work. So we're going to rotate it so that it is in between the two fins. There. Click OK. So you can kind of see it there. I don't know if it's kind of in between the tubes there. So we've added our body tube, and then oh, I forgot. You're supposed to add the nose cone first. So we'll add the nose cone. It needs to go above the body tube. I was thinking tube fins, so I didn't think about the nose cone going first. Yes, yes, yes. I have no nose cones. Okay, so change my view there. And zoom in so we can see what we're doing. So the length of the nose cone, the diameter, I think that's what I put my tube fin diameter as, and then the base length, that's just if it's like conical and then has kind of a flat section there. Let's change the shape so it's a little bit more there. You can see there I've got my little nose cone on my body tube. And then we don't want it to be solid, that would be really heavy. Put a wall thickness for there. So if you choose from the database, you don't have to do all that stuff, but since I'm doing this manually, so we'll click OK. Ooh, I'm really zoomed in now. So you can see I've got my nose cone and my body tube for my pod. And this is all there. And then if you want, you can play with the location because it's a little far back now. And then if you wanted to, like say we didn't have, well, you would need fins of some sort because this won't function as a fin anymore. But you could add a streamer inside of it. If you wanted to make this a one that pops out, you can add an inside tube in the body. So once you've set your pod from here down, it's just like another rocket. You got a nose cone, body tube, you can put fins, you can put an inside tube in to put a motor in it so that, you know, if you've got a rocket with, you know, a central motor and then 2 outside motors. So you can do all of those things. So that's how that would work there. Just checking time to make sure. So Jerry, I hopefully that answers your question. I didn't go through, you know, every single option of what you can do with this. The video tutorial I showed you beforehand goes through putting a streamer in there, putting a motor in there, having the pod pop off. Sorry. But that's how it works, as pods is what it's called. So you're gonna have a strap-on booster pod of some sort. A pod, even if it doesn't function as a booster, even if it's just a, like a fake missile or something and it's glued on, you just start with the pod, your invisible glue, and then add your nose cone, your body tube, your fins, whatever you want to put on there. And the other thing is, so say I wanted to add one on the other side, you can highlight your pod, right click, and copy, and then go back up to your body tube and paste. And so now I have pod 1 and then the duplicate of pod 1. So this will be pod 2. And then right now they're going to be in the exact same spot, so you won't be able to see both of them. But if we change the radial direction here, so now you can see there's 2 of them, and you can see in this now we've got I'm zooming, 2 of them on there. So once you have your pods all set up, you can copy paste to add more. So you could do 2 or 3 or whatever. You can put some up more up front or more in back. But yeah, that's how that works, Jerry. So hopefully that answered your question. If you have any more questions, just throw it in the chat or send us another email. But that's how that works for that. So the next question we had, which is kind of related, so I'll take this one. And next is there was a customer who emailed us, and his rocket wouldn't fly, and he couldn't figure out why. And I think it was this guy. Yeah. So he would load an engine in here. I don't have engines either. Okay, I'm gonna have to find my engines real quick. One second here. Okay. Yeah, I pulled the data folder out. I was also going to talk about this later. We've had some questions about, it's mostly on Windows and I'm on a Mac, so it will be a little different, and at some point we'll make a tutorial for this separately. But if you are missing your motor or your parts files, there's a video on how to do that on the website, but it's a little confusing because the video is just talking about motors, how to load missing motors back into your RockSim, and it's not actually correct for parts, or it's partially correct. So under how-to and guides, software, notice we come here a lot. How-to and guides is the place to be on the Apogee website if you're not shopping. And software, and loading missing motors back into RockSim. So this video tutorial that Tim does shows you how to load the motors back in by using the file import engine files. There used to be an import database files, and for some reason I don't know where this went, but it's not here. So you can't do that for if you're missing parts files. So the workaround is to just put them in the correct place to begin with. And you can download the files from here, your motor files, your engine vendor lists. So that's Aerotex, Aceroni, Gorilla, you know, all of the vendors, Estes, and then the parts databases, nose cones, tubes, and everything. Mine were missing because I actively put them, took them out. So you have to get to the data folder, and the data folder is hidden. And so on in Windows, it's pretty easy. You can change your settings. On Mac, the way to get there is to click on your desktop, click on Go, hold down the Option key, and you'll see this library shows up. Application support, Apogee components, RockSim_1 for RockSim 10, data, and my files are here. That's weird. Okay, so clearly my RockSim's looking in the wrong place. So you would put your missing files in this data folder. Since mine are here and RockSim isn't showing them, this tells me that it's looking in the wrong place, which I may have also messed up when I was testing problems for a customer. So to reset your location, so to factory reset RockSim, you just go to Preferences, Miscellaneous, and oh, see, yeah, it's looking for a desktop folder that doesn't exist because I changed it. And you just click Factory Reset and click OK, and then RockSim will restart because any changes to the database, it only recognizes them when it first boots up. So if you open RockSim, make a change, you know, drag the files in, it won't show up till the next time you restart. So now I should have my files. So let's reopen that rocket. This guy. And then choose an engine. Yay, I have engines. So when in doubt, factory reset. That'll reset all your units and things too, so just be aware. But that's fine, you can fix those real quickly. So we're gonna choose an engine here with a delay. Okay, launch. Oh, and of course this is gonna work for me just fine. He was having problems like this where it wouldn't launch. If you see the little rocket on the pad with a little X, basically it means it never left the pad. He said he left it running all night and it just kept kind of running. The reason that can happen, sometimes there are pods or sub-assemblies that can cause issues. So this is a sub-assembly here. You can make a sub-assembly to, say you make a motor mount that you want to use in multiple rockets. So it's got your two centering rings, your motor mount tube, maybe an engine block, maybe a retainer or an engine hook. You could make a sub-assembly so that's all one piece. So that next time you do a rocket, you can just throw that sub-assembly in. But there's a weird thing that happens with sub-assemblies sometimes where they cause problems. Sometimes they work fine, sometimes they don't. Like I was able to run this simulation just fine, but the customer wasn't. Especially if it isn't your file to begin with, if somebody else makes it, sometimes it will cause problems. So if you ever try and run a simulation and it runs forever and ever, or it won't run at all, check. This is Carlos. This is one of those things that to check. The easiest thing to do is just delete. Unfortunately, delete. But delete your subassembly from the rocket. Try flying it again. 9 times out of 10, it will work just fine. So then you know it's a subassembly. And unfortunately, the fix for that is to just re-put the parts in manually, one at a time for that, because there's something wrong with the subassembly file that's like corrupting it. So yeah, the other thing, if it doesn't leave the launch pad at all, like his ran. That to me says pods can also sometimes do it, especially if you've got a ton of pods on your rocket or pods on pods, like really complex things. Sometimes I think it just gets confusing, or things start like getting overlapped a little bit or something, I don't know, but can cause that problem. So when in doubt, maybe save the file as an alternate name, start deleting parts. We went over that the last time I did RockSim Live, back in September, I think. But if you have a problem with a rocket where it's not flying at all, you can start just deleting parts and get to the point where you can fly it, and then work your way forward to figure out which part was the problem and what you need to do to fix it. The other issue, which is less of an issue with 10 now, but in previous versions of RockSim, and Carlos, this is another thing to check. If it won't launch at all, check your parts materials, specifically your fin material, but it can be other parts too. Most of the time it's fins, but I've had it be other things. Check your fin set and make sure it has a material here. There was a situation a long time ago where it would say custom. What is custom? What's the density of custom? RockSim doesn't know, so you can't fly. I don't know. So it has to be a material, an actual real life material. So you can calculate the density. So if it won't launch at all, check your materials, make sure it actually is a material. Also make sure it's a material that's in your database. If you got the file from somewhere else and say it says, your fins are made out of bubble gum, something, whatever, and bubble gum isn't in your database, RockSim's not going to know what to do with it because it doesn't have the density built in, because RockSim does have a density database. I can show you that. It's under the Rocket menu and then edit databases and materials. This is where all the densities are stored. So if you ever want to add them, say you want to add bubblegum as a material to your database, this is where you would add it. So this is where all those densities are. So if your part is made out of something that's not here, RockSim doesn't know what the density of it is, and it just breaks. It just can't. It doesn't assume it's zero. It just doesn't know what to do and won't move forward. So, yeah, that is something else to watch out for there. Okay, let me just check in here on the questions. We got Jerry says the training will help. Good, Jerry. Hopefully that gets you going. Luke says he got his L1 with our rocket kit. That's great, Luke. We love hearing that. So Johannes says, I see no motor tube in this model. If you're talking about this one, okay. And then he says, maybe a stupid question, but I'm Dutch. What is the difference between a motor and an engine? So this comes back to the beginning, which you might have missed, Johannes, but I was talking about how the same item can have different names. A motor and an engine, they're the same thing. It's just different terminology. So, we call, in the United States, we call the storage area in the back of a car a trunk. In the UK, they call it the boot. It's the exact same thing, it just has a different name. Motor, engine, they're both the same word. So in cars, it's the same thing. You can call it an engine, you can call it a motor. Technically, they're probably different in that case, because the engine might be the whole thing and the motor might be, the actual parts that move. But in terms of rocketry, motor and engine are the same thing. So Johannes said he didn't notice a motor tube in this rocket, and he is actually there might be like a weird tube sleeve, but rockets don't always need a motor tube. They actually there's something called minimum diameter rockets, and the way that works, let me switch my feeds real quick. I can show you on this rocket kind of. Oh, my little flyout's coming out again. So this is not minimum diameter, but I have a rocket here. So if you can kind of see, I've got the motor mount tube in here. So this is an 18 millimeter motor mount in a 33 millimeter. This is a bad example, but 33 millimeter rocket. If you take the motor mount tube out, if this were say like a 29 millimeter tube, you could put a 29 millimeter motor directly into the body tube. provided you don't have things like through the wall fins. But the body tube can function as a motor mount tube. So that's called minimum diameter. And it looks like that might be the case for this rocket. You can see here that the motor goes straight into the body tube. And you can do that in RockSim. You do have to tell it. Yep, see, so when I open that back, so it's a body tube, but I've checked this box to say this is a motor mount. So this is telling RockSim that even though we said body tube, not inside tube, we're gonna stick a motor in here, and it tells it what the diameter is. So you can use minimum diameter. Minimum diameter is pretty common when you're trying to reach altitude records, so you wanna go as high as possible. Our Aspire rocket that we sell can be a minimum diameter. It comes with an optional motor mount. And if you fly it on as a minimum diameter with the 29 millimeter F10 motor, it'll go a mile high. It goes over 5,000 feet. So I don't know if I have a base view of this rocket, but so this is the Aspire, and this is a 29 millimeter tube. And so the motor goes straight into that body tube. This guy put an H13 in it and got 8,900 feet. This rocket's only like 3 feet tall, and it's only an inch, just over an inch in diameter, and he got it. I don't know how he got it back. That's the question, is did he? But yeah, so you can stick the motor directly into the body tube, and you have to get a little creative on how to hold that motor in there. You would use tape, probably. That's what most people use for that. So yeah, so that's how it works if you don't want to put a motor mount tube in there for that. Okay, Mark Sell sent in an email asking a question about his rocket. Basically, he was saying that the rocket was unstable, but no matter what he did, RockSim kept saying it was safe. And he couldn't exactly, well, pretty much, some of them probably not, but kept saying it was safe, and it, even though it wasn't stable, and he had said that sorry, I don't have the email right in front of me, he had set it to no wind, and just basic launch rod, and he was trying different things. So the first thing I noticed right away when I opened this file up is it's not unstable. It is overstable, it says right here. So overstable and unstable are not the same thing. You may think that is, and I keep asking, expecting a different answer of like, oh, isn't overstable not stable? Or is there a point in which it's too overstable? I've seen overstable rockets in RockSim at like 30 overstable. So the margin, this number here, it's a caliber. And what a caliber is it's the diameter of the body tube width. So in this case, this is a 1/2 inch diameter rocket. So if a margin of 1 would be 1/2 inch, or just over 1/2 inch between the center of gravity and the center of pressure. So to be stable, you have to be at least 1 body tube width distance between your center of gravity and your center of pressure. In this case, in Mark's rocket, he is 6 times the body, so about 3 inches difference between the center of gravity and center of pressure. So when a rocket is unstable, what that means, and this is one point for Mark, he'd said that he had set it to no wind. So an unstable rocket with no wind could possibly fly stable. And the reason for that is because the whole point of the stability is what happens when wind hits it. So if there's no wind, I mean, it is completely dead, which in Colorado that never happens, but I'm sure some places does. If there's no wind at all, even if your rocket's not stable, you might get a stable flight, decent flight out of it, because you're going up, and if it's going, 30 miles per hour off the launch rod, and there's nothing to keep it, going off center, it's just going to keep going. And so it might fly beautifully. You don't want to do that because, again, wind, and it might be calm here on the ground, but 100 feet in the air, there might be a thermal or a gust of wind or something for that. So that's why it's a safety issue of it's not exactly that the rocket won't fly stable this time, it's that it could potentially not fly stable and could hurt somebody. You don't want to count on it being calm, because it could be calm right until you push that launch button, and as soon as you hit it, a gust of wind could come, and then that rocket could go sideways and hit somebody, hit a car, things like that. So overstable, what happens with overstable is that what your rocket might end up doing when the wind hits it is it'll weathercock into the wind, so it's trying to correct itself. Weathercocking is when the wind hits it and it tries to correct. There's a whole bunch of information about dynamic stability if you want to get into the nitty-gritty of this. Model Rocket Design and Construction book has a whole chapter on it, or 2 chapters, I think. We've got stuff on our website, but basically when the rocket leaves the launch pad, it needs to correct. And if it's unstable, it's going to go wee. But if it's overstable, what it might do, or what it likely will do, is it's going to correct and then go. So your rocket will probably go up more like this. I sort of think of it like, maybe if you live somewhere where it snows, but when it's icy, if you've ever seen like a pickup truck, it doesn't have enough weight in the back, so it'll go up a hill like this instead of going up straight, whereas like a 4-wheel drive car or maybe a front-wheel drive car will go, but a truck will go up kind of like this. So it's kind of the same idea. It's correcting, but it's overstable, so it's overcorrecting basically. So your rocket might go up like this, but it's not going to go all bonkers. It's just going to be a little bit crooked. So that's what can happen with overstable. So overstable and unstable are not the same thing. So if your rocket is overstable in RockSim, good, that's totally fine. If it's a margin of 1 is the minimum, but 1 is, that's assuming that everything is exactly right in RockSim. So, there's always a little bit of a wiggle room. So, margin of 2 would be fine. 6 gets pretty big, but you're just going to get more weathercocking. Like I said, I've seen ones that are like 30. Yeah. Then, and then what I would also say is if you have a rocket that's unstable and you're still seeing stable or safe results, put some wind in there. That's going to immediately, Tim won't run a simulation less than 8 miles per hour wind. He runs all of them at 8 miles per hour now, because that's a pretty standard, 5 to 8 is pretty standard for most places, especially if you're out in the middle of nowhere. There's always wind out there in those fields. So you run it with wind, and that will give you a better, more accurate approach. And to do that, if you don't know how, let's, oops, I didn't mean to do that. Switch my view back. So we load our engine in, choose engine, let's choose that here. And then, so these are all of our different events. So starting flight events, when does your streamer deploy? Simulations control, that's like how many samples per second. Starting state, how long is your launch rod? That also is something, Carlos, you were talking about things to check. This is one of those things to check, because if your launch guide length is set to say maybe 96 inches, like an 8-foot rod, but you're not flying on an 8-foot rod, your rocket might not be, especially if it's marginal, it may not be safe to fly. You want it to be going 30 miles per hour when it leaves the launch rod. So put in your shortest launch rod that you might be using and start there. You can always add length to it later, but yeah, always go short on the shorter end, because if it's 36 inches and it says 96 inches or 92 or whatever 80 in here, it's going to say, oh, it's fine, and then you're going to go fly it, and it's not going to be fine because your launch rod's like half the length. But launch conditions, this is where you change all of your different things, your temperature, your barometric pressure. Carlos, this is another thing to check. We get people who are like, my rocket won't leave the launch pad, and they send me their file, and they've set their barometric pressure to like concrete. So like the air is so dense, it's like concrete. Well, no wonder your rocket can't launch, because you're apparently flying on another planet that is got crazy pressure. So check that. But here's your wind conditions. And if you do custom speed range, low of 8, high of 8, so that keeps it from getting like gusty. This gives it kind of a constant, and then that way you know it's always that. So set your wind conditions to 5, 8 miles per hour when you really want to check the safety and stability of a rocket if you're questioning it, because no wind is going to be better. So you always want to check, like I said, that the shortest launch rod, the wind, check on the high range. Obviously, if it's, the wind is 15 or 20 miles per hour, you're not launching, at least not with a club. They won't let you launch that high. So, but 5 to 10, usually you can, so check that there. Then we click launch and it flies. And so this says it's safe. And the thing you can see, whoops, I haven't played with this in a while. So we're actually going to show this here when you run the simulation is the weathercocking cone. This is where it's safe. So as long as it stays in here, this is what Mark was talking about it being safe, showing it safe. It's staying in this cone. So let me show you what happens if we... So I deleted the nose weight. So you'll notice now the margin is -2. It's unstable. Our CG is behind our CP. So this is not safe. You don't want to fly this rocket. But let's see what happens here. See, so now it says unsafe. I'm going kind of fast, sorry if I'm clicking through here. So now when we launch it, see what, whoa! See what, hopefully you can see what that just did. Let me slow it down. This is the fun stuff to do in RockSim. This rocket is doing cartwheels. This is what unstable means. So this rocket, it'd be cool to see, but it is not safe to fly this. That's the difference between unstable and overstable right there. So there's that. Mark's question was, is there a place where your CP should be? Because his CP is pretty far up. It's like halfway up the rocket. And so he was wondering whether or not that is safe, or if there's a place your CP should be on rockets. This rocket has really tiny fins on it. And so that can be a problem for stability, which it is, which is why he has to add so much nose weight to it to make it stable. And the answer is no. The CP is wherever the CP is. If your rocket's unstable, you can make the fins a little bigger. You can add nose weight. You can make the rocket a little longer. Those things all move, the CP or the CG. What matters is that margin that we were talking about. The distance between your center of gravity and your center of pressure needs to be at least 1 body tube width. Where the center of pressure is doesn't matter. It's, if it ends up being all the way at the front, towards the front of the rocket, as long as your center of gravity is a whole body tube or more further for it, then it should work. So there's just not, it's more common to be more in the back half of the rocket, definitely, because what happens is, I don't know how much nose weight was in here. Let's reload this rocket. So let's look here. Like he's got 3.5 grams of nose weight in this tiny little rocket. Like there's a point at which your nose weight is just, it's going to be way too heavy for such a tiny little rocket. So that's where you get into that discussion about your center of pressure. It's not that it needs to be in a certain place. It's just that what you have to do to get your center of gravity forward of it is going to get to a point where it's ridiculous, where it's just not going to work. Your nose, you're going to have, a bowling ball inside of a tiny little rocket. You're not going to be able to get enough weight into it. And that's when you start going, okay, maybe if I make the fins just a smidge bigger, and we've done that for like some of our rockets that we sell or plans that we've done. We've come up with a great idea, or we've got a scale rocket that's exactly to scale, and then we go to fly it and it's unstable and it goes willy-nilly. So sometimes you have to cheat and you make the fins just a smidge bigger, or the tube a little bit longer, a little cheat to make that work so that it'll fly stably. If it was a display model, you can get away with whatever you wanted to, but if you want to fly it, you have to make it stable somehow. yeah. So Mark, hopefully that answered your question. I don't think it's the answer you wanted, because I felt like you, in your email, you really wanted there to be a kind of a right answer. He was upset that his rocket wasn't going unstable, and it's not often that people are not upset, but like he was just confused why it wasn't going unstable. My rocket keeps saying it's safe to fly, and it's just funny because usually it's the other way around. The questions we get, they're like, "Oh, RockSim keeps saying it's unsafe, but I've flown it, it's fine, or everything looks good." And he just kept trying. But it's cool because what that means is Mark was playing with the software, trying different things to try and get to do that. And that's what's great about RockSim, is that you can do all those fun things you couldn't, you wouldn't build a rocket 15 different times to test that out. But in RockSim, you can just, delete that nose late and boom, it's as simple as that. So that makes it a lot of fun to do. So we're coming up on the end of time. So I'm looking for questions here. Okay, we got some more people in here. So Johannes says, my tail sections always turn out to be heavier in reality than my simulations. And Johannes, that comes back to that materials database that we were talking about. So if you add a tail cone, one of the things is that like density for items is not always set. Say we add, in here, so you have polystyrene. Well, what the density of polystyrene maybe, or PVC, especially the woods, wood density is really impossible to like have one answer for, because it depends on the epoxy in there, the density of the wood. When we order balsa wood from our supplier, sometimes they say, we're out of the light, do you want medium or hard? Well, that means the weight of those fins, the density of those fins has changed. Even though they're all the same balsa material, they just have different densities. So that's probably what's happening, is that, the density of whatever that your material you're using, fiberglass, again, the epoxy to fiberglass cloth ratio, those get a little bit different. It can be different. So what you can do, if you want to, is you can do a mass override for that part, Johannes, and just, especially if you're using the same part over and over, so you can just change the mass of that tail cone, and once you have it measured, you can even save it, if it's a custom part, save it to the database by going here. So you would just say like, Johannes tail fin, you're the new manufacturer, give it a part number, and then you can save it to use later on. You just save it to the database. So if you have a part like that that you're using over and over, or you can edit and save it there for that. Okay, Boku says, is that software Java based too? Right now it's a desktop program. And I'm not a programmer, so I don't know exactly what all is involved. We are working towards a cloud-based version of RockSim, but we are not close to that anytime soon. The way RockSim was built many years ago, it doesn't translate directly to the cloud. You can't just take the code and throw it in the cloud and it works. It has to be rebuilt from scratch, basically, and we're working towards that slowly, but it's not going to be real soon. What we do have in the meantime is Tim's favorite thing ever right now, which is the launch visualizer, which is the flight portion, the simulation portion of RockSim. So you have to design your rocket in RockSim, but once you have it designed, you can go to the launch visualizer and launch it in 3D. This is all cloud-based, there's nothing on your computer. And you can go there now. It's in beta testing right now, so once we are ready to go live, we'll kind of wipe it and start over. But you can sign up now for a free account, or you can play with it without even having an account if you go to rocksim.com. So there's a couple rockets already loaded in here. There's some demo ones. My demo ones are different because these were the demo ones when I signed up, and there's a bunch more now. You just choose from there and select the rocket. These are the same things as RockSim, your launch site information, your starting state, that's your launch angle, launch guide length. You see them grayed out. The free version, the free not signed in version, you don't have access to a lot of this. You can then, if you want to, you can sign up for a free account. Right now they're all free because we don't have the paid version up yet, but and that will give you access to a few more things. But if you come down here, you can load an engine into it just like you can in RockSim. And I'm whipping through it really fast, but all you have to do if you want to see how to use this, go to one of the other RockSim Lives. Tim spends a lot of time going over RockSim Live every time. Or go over the launch visualizer and the RockSim Lives. You click the launch button. Yes, I'm not a robot. And then it will run a simulation, and hopefully this works okay. And so there's my rocket on the pad. And then I launch it. So this is and it's stopping at Apogee because this is the unsigned in version. That's where it stops. But you could sign out here. You can see this is the launch field that we launch at in Pueblo. That's about an hour away. So you can play with that. And then you click here to get out of that. So there is that, but we are working towards, we do realize that RockSim is, needs to be updated, but it's just not as easy, and we're not a software company. That's something that I think people don't realize. Right now I think we have 10 employees total, and 99.9% of us aren't programmers. We're in the hobby business. So we have people working on it, but we don't have, 100 programmers or 1,000 programmers working on it like Amazon or Microsoft or any of those. So just bear with us, please, for that. And Mark says he reran the simulation and removed the nose weight. Yep. Johannes says glue, large paint area and filler in the fins. I always check the real center of gravity because your weights can be off. That's also smart, Johannes. So in RockSim, you have your rocket and it's going to say where your center of pressure is, where your center of gravity is. But then what you need to do is take your actual rocket and figure out where the center of gravity is. And that can be as simple as just balancing on your finger. Remember, so this is without the motor in it, just be aware. So ideally, you can check it without, but you'll want to check it with the motor in, because that's the other thing. That's the other thing, Mark, too, that I forgot to mention on yours as well, is your rocket can be overstable, but when we load a motor into it, it's going to pull that center of gravity back. So, I deleted the nose weight, but the motor does add weight to the back of the rocket, which pulls your center of gravity back, and so now, it becomes a lot closer. So that's another thing that when your rocket might seem like it's overstable or too stable, not too stable, there's no such thing really. Once you load the motor in, that's going to change a little bit. But you'll want to find your actual center of gravity. Balance it on your finger. So that's what, like 9 inches maybe back on this guy. And then you can go in, and if it doesn't match, you can go to this mass override tab, and you can change your total rocket mass. Like he says, if there's glue, paint that can add to your weight, so so this rocket, this is not the same rocket as this one, but this rocket says it weighs 6.9 grams. Well, say Mark goes to fly it, and without the motor in it, well, this is with the motor, but it's 7.2 grams or 8 grams or something. You can use this mass override to adjust the overall weight. So let's say this is actually 8 grams. And then your center of gravity, you have to put your center of gravity in there too. So this is a totally different rocket, but we're just going to put it in there. 9, so this is 9 inches back, that put away back. If you don't put the center of gravity in here and it defaults to 0, it doesn't compute it automatically. It says the center of gravity is at the tip of the nose cone, or the tip of the part. And this has got the motor in it, which is why it's confusing. There we go. So see how this says 0? Your center of gravity is at the tip of the nose cone, and it's going to be wrong because your center of gravity, no rocket balances here. There is no rocket that you can put here and it does that. So you're going to get false stability results, and then obviously bad simulation results too. So always, if you're going to use the mass override, always put the center of gravity location in here as well for that. And Carlos, this is another thing to check. This is really important when you're checking kit files, even if they're yours and you just did them a while ago. We run into that sometimes where we can't figure out what's going on, and then we suddenly realize this is turned on. But say like Mark's rocket here, he had that nose weight he added. So we're going to add a mass object. Sorry, my reminders keep popping up. We're going to add a mass object to the front of the rocket, and you'll put it in the right place. So our mass right now is 8 grams. We just added something and it's still 8 grams. So you're not, if you make changes to the rocket and you notice there are no changes in the weight, that's a little red flag that you've got mass override turned on. So you'll need to turn that off before you make your changes, because they won't be reflected otherwise. So that's one of the biggest things I run into a lot with RockSim, is I get people who are saying RockSim's not working because I make changes to, I made my fins huge and the mass didn't change, or my center of gravity didn't change, or things like that. And it's usually because this mass override is turned on for that. So yeah. Apparently Tim is logged in and watching as well, so hopefully you all think I'm doing as well as Tim does. So it looks like everybody's we got everybody covered for today, so that's good. So yeah, basically if you're having issues with RockSim, play with it. Most of the time it's delete parts or change things, check your settings, make sure you don't have overrides turned on, play with the wind. That's how you really learn how the software works, and also how to troubleshoot. Other things quick that I can think of, Carlos, if you have a rocket that won't launch, if you go to load the engine and you go to starting state, check for your launch angle. You'd be surprised at how many people will send us a file and it'll say the launch angle is like 90 degrees. So your rocket's launching like this, and they're like, it won't go anywhere. And you're like, because you're launching it like this. That one, sometimes I think people don't realize, like, I'm not clicking on anything, it's moving just because I'm moving my mouse or my trackpad. So sometimes I think that one gets a little touchy and people don't realize it's moved. We've even done that ourselves. We had one person who was doing recommended motors for a kid, and all of a sudden none of the motors worked, and she spent hours trying to figure. It's because her launch angle went like this. So it happens even to us sometimes. But just check things, and if you're not sure, check out like I showed you guys at the beginning, those video tutorials. They're really, sometimes people just don't want to bother, but the answers are there. They're really helpful. I point people here all the time. I watched this before we started this live to refresh my memory on how this works. Even if you know what you're doing, maybe there's something you forgot to check a box or something. So these are really helpful. And if you have done all of that, you've done your research, and you still have a question, send it in to us through the contact form here on the website. You can just fill out the email information and send it in. Tim can talk about it in the RockSim Lives. We can email you back answers to the questions. We're here to help. And almost every question I think we've come across before, so we're pretty good about answering. But who knows, maybe you have a unique question we haven't come across before. And if you get a chance, check out rocksim.com, the launch visualizer. We're so close to going live with it, but right now it's free and you can just play with it. And there's still a couple bugs we're working out, but it's on the home stretch, so we're really excited about hopefully launching that pretty soon. So I think that's everything for today. Tim should be back next week, so send in your really hard questions for him. These ones were awesome today. Thank you guys. They were good ones that I could answer, and I was excited that I didn't have any crazy ones. Tim likes the crazy ones. I get a little scared. So yeah, until next week, thanks for stopping in. Bye.